Hello, I'm Dywetes, and I will be going to show you how we solved numbers 7 and 8. Number 7. It is said to be that for letter A, we have to find the rate law for the reaction, in which we can get it on the reactants of a chemical equation. So, based on the chemical equation given, we found out that the reactants are the selenious acid, the iodide, and the hydrogen. But notice that it does not have its corresponding exponents, so we have to solve for x, y, and z to get its rate. By solving it, we have to get a ratio of 1 in every reactant based on the experiments. To solve x, we used experiments 3 and 1, for as we can see in the table, its other reactants has a ratio of 1, like the iodide here and here. This is 1:1, and so in the hydrogen. By using the formula of rate law, which is rate equals constant a raised to the power of x, b raised to the power of y, and c raised to the power of z, we then substitute the values of the initial rate, the initial of the selenious acid, the iodide, and the hydrogen in each of the experiments that we used. So let's try to solve it. These two will be cancelled out. So what's left are this. To calculate it, we then get 4 equals 4. So the x will be equal to 1. To solve for y and z, the process will just be the same as what we did in solving x. So for y, we used experiments 2 and 1 and substitute its values. By calculating it, we get 8 equals 2, in which 2 is raised to the power of 3 is 8. Therefore, y is equal to 3. And for z, we used experiments 4 and 2. And then again, let's solve it by substituting its values. So we get 4 equals 2, in which 2 raised to the power of 2 is 4. So z is equal to 2. Since we already get x, y, and z, the rate law for the reaction is rate equals constant selenious acid, iodide raised to the power of 3, hydrogen raised to the power of 2. So that will be the rate law for the reaction. For letter B, we have to find the value of K using the data in experiment 1. So the formula that you will be going to use is that on the answer of our letter A, which is this. Rate equals K, or constant, selenious acid, iodide raised to the power of 3, and hydrogen raised to the power of 2. Then we will simply substitute its value found on the table or data given. So we substitute the initial rate, which is 9.85 times 10 raised to the power of negative 7. And then on the right side of K are the values of selenious acid, iodide, and lastly the hydrogen, which has the same value as iodide. Then after substituting all of it, we then first multiply the values of selenious acid, iodide, and the hydrogen, in which we can get 1.9 times 10 raised to the power of negative 12. So to get the value of K, we have to divide it by 1.9 times 10 raised to the power of negative 12 in order for it to be cancelled out. So the equation will be then derived. It will become K equals 9.85 times 10 raised to the power of negative 7 divided by 1.9 times 10 raised to the power of negative 12. Calculating it, we then get the value of K, which is 5.2 times 10 raised to the power of 5 liter per mole second.